Welcome. This recording is about week 6 lecture of the course Insurance Risk Model. It is an update about Spearman's rank correlation. We have seen in the lecture that the usual correlation coefficient that you all know is called here the Pearson's correlation coefficient. Spearman's rank correlation is very similar to Pearson's correlation coefficient. To understand that, consider the CDF of a random variable. And if you take one value of x and put that in relation to the value of the CDF, you can draw a certain number of conclusions. I'm sure you've seen in previous lectures that you can simulate values of x by simulating a uniform random variable. So what you will do in that case, if you are doing a simulation, you are simulating a uniform random variable, and you plug that in the inverse of the CDF and you will get x. The result that you're using when you do that is that the inverse of a uniform random variable is x and has the distribution of x. Similarly, if you look at f of x, this value, the value of the CDF evaluated at a random x, will be a uniform random variable that is distributed between 0 and 1. It may look a bit strange at first sight, but it's true. If you choose any value of x along that axis and then map it against f of u, if the value you are choosing in the x-axis here has distribution of x, then the map of this value on the y-axis here will be a uniform random variable between 0 and 1. So when you're looking at two random variables together, they might have the joint distribution of these two random variables, they might have a certain dependence structure. But these two random variables may have a different distribution. X could have a range between 0 and 1, and y could have a range between minus the infinity and plus the infinity. So when you are calculating Pearson's correlation coefficient, you are using these two random variables. But now you can do a transformation on these two random variables and look at the pair of the CDF of these two random variables as random variables, and they will have the same dependence structure. But these two things are uniforms. They are both uniform random variables between 0 and 1, but they keep the dependence structure that you had before. So Pearson's correlation is done on this pair. And Spearman's rank correlation is done on this pair. And it's the same formula. You are calculating the Pearson's correlation coefficient, but on these transformed random variables, and both are uniform random variables. So in other words, if we come back here, if you do your correlation on this uniform, this is Spearman, and if you do your correlation on the raw random variable, this is Pearson.